All right, so working through a review, one question of graphing, the one on your test may not be super similar to this, but it'll be the same concept here. There are 3 of these on that other review document. So let's do this one, and then you should practice with the other 3. So first thing to tell you is that you get a reference sheet during this test tomorrow. So the copy of that reference sheet is posted at the Google Classroom. It has a lot of information on it about graphs of sine and cosine. It tells the formulas and how you calculate the period and the phase shift and the vertical shift and all those things. So I'm going to hand out a copy of that, but if you are working on this independently, you could always pull the reference sheet up at the Google Classroom. All right, so I would probably start this by saying this equation is y equals a times the cosine of bx plus c plus d. Remember all that? All right. The reference sheet tells you the formulas for vertical shift, amplitude, period, and phase shift. Okay, vertical shift is d. Amplitude is the absolute value of a. Period is 2 pi over b. And phase shift is negative c over b. So you don't have to memorize those. Those will be given to you. You just need to know how to analyze and apply them. So you can look at this equation. What's the vertical shift? 2. Okay. What is the amplitude? The absolute value of a would be the absolute value of negative 3. So I would call the amplitude 3. But I'm going to make a note here. What does this negative sign do to the graph? Flips it, right? So I'm going to make a note here that this is going to be a reflected cosine because of that negative sign, which means it's going to begin, instead of a maximum, it's going to begin with a minimum. So I'm going to write that here. You don't have to write it when you take the test, but you have to acknowledge it and apply that. So don't forget to reflect that. Okay, to calculate the period, take 2 pi divided by what? 4. So 2 pi over b is 2 pi over 4, and that reduces to just pi over 2. The phase shift is the opposite of c over b. And you can look in that equation, c is negative pi over 2. So we want the opposite of negative pi over 2 divided by b, which was 4. Now, this takes a little work. We have a fraction and a fraction. We need to simplify this. How do we divide by 4? Okay, we multiply by what? All right, so this becomes positive pi over 2. Instead of divided by 4, it's times 1 over 4. I've had people write times 4 over 1. 4 over 1 is not the reciprocal of 4. All right, 1 over 4 is the reciprocal of 4. And then you have to know on this test, how do you multiply fractions? You just multiply the numerators, multiply the denominators. So the product here is pi over 8. That is the phase shift. So calculate the 4 features, and then we need to start applying them to the graph. Okay, the first thing I would acknowledge on my graph is the vertical shift of 2, and I would label my y-axis with a 2 at the midline. And then I know the curve is supposed to have an amplitude of 3 units, so I'm going to go 3, 4, 5. Up here at 5, you can put it in or not put it in, but that's how tall my curve should go. The maximum height should be up at 5, and then 3 units below, down at -1. So I'm going to use the whole space for this particular graph. All right, so that accounts for the vertical shift and the amplitude. Next, accommodate the period of pi over 2. This is exactly what it was when we practiced these. It says it in the instructions. You're to graph this for exactly 2 periods. So if the period is pi over 2, where do we label pi over 2? Along the x-axis. Okay, at the end? No. okay, at the halfway mark. That way we can double that, okay? This is half pi, then out at the end is pi. And then we practiced, if you want full credit, you have to scale the x-axis. And you're going to want the scale anyway, because then at the end you have to check some points, and it's helpful if the scale is listed. So if this was pi over 2, then back over here, half of pi over 2 makes this pi over 4, right? And then half of pi over 4. Take pi over 4 and times by 1/2. It gives you pi over 8. So we talked about how you can go across. If you can work your way back to the first hash mark of pi over 8, then just keep adding that. What's pi over 8 plus pi over 8? It's 2 pi over 8. And then 3 pi over 8. 4 pi over 8. 5 pi. Eight pi over 8. So you don't have to label all the way out on that, but you could. And then just reduce the fractions. So okay, so it takes a lot of work to get it all set up, but at this point you're ready to actually start putting the curve in place. All right, the curve is a cosine that's been reflected. And so to plot the first point, I'm not going to start with a maximum. Let me go here. I'm going to start with a minimum down at -1. Okay, it's going to be a cosine that instead of starting at the maximum, it starts down with a minimum because it's a reflected cosine because of that negative sign. So if it starts with a minimum, that at the end of the period, it'll have reached a minimum again. Okay, so I got the first point, the last point. The midpoint is going to be a maximum. And then intercepts in between there. So there's your curve, right? It's going from the bottom up to the top and back down again, and then you can plot the rest of the points. Okay, I don't care if you do sketch this all the way in or not. If you do, make sure it's not too dark. I want to make sure you are clear that that's not the final curve. All right. This graph has everything applied. It has the vertical shift of 2. It has an amplitude of 3. It has a period of pi over 2. It is reflected. It is the cosine. The only thing left to do is apply the phase shift. What does the phase shift tell us to do? If it's a positive phase shift, we move which direction? Okay, to the right. So take every point that was on that temporary graph and move it to the right. Pi over 8 is 1 unit. Okay, every point gets moved 1 unit to the right. All right, technically, if you don't want me to dock you a quarter point, make sure you graph it for the full 2 periods, so you'll have to backtrack. But you all have graphed these enough to know where to go at the beginning there. All right, now, this is good, but you're not going to get more than half credit, even if you just make one tiny error, okay, if your graph is off, because it will have one of those things where you circle yes or no. Is this graph correct? So how do we check our answers on these? Okay, should I check 2 points that are both intercepts? No, because that doesn't prove whether the graph goes up or maybe it goes down between them. So don't choose 2 intercepts. Choose 2 different types of features. I'm going to choose a minimum and then an intercept. You have to name those coordinates. So this bottom point here is right pi over 8, and it's at -1 on the y-axis. So there's a point that I could check. And the other point at the midline there is right pi over 4. And that's lined up at a y-coordinate of 2. So when you're going to check these, save yourself from getting stuck, what mode should you have your calculator in? Okay, if you're not in radian mode, you're going to think your answer's wrong, when it's right, and you're going to lose some time and waste some time. So just make sure you're going into radian mode. Put that x coordinate in, -3 times the cosine of pi over 8. You don't need any parentheses here. 4 times pi over 8 minus pi over 2 plus 2. It equals -1, so the first point checks out. Once you've typed that in once, you can just change out the pi over 8 for a pi over 4, and that checks out too. So make sure that you know how to check your answers so that you can accurately circle yes or no on that question. All right, I'm going to look at question number 2. Okay, now we're going to go the other direction. You have a graph, and you need to write the equation. So we divided this graph up. If you want a highlighter while you're taking the test, you certainly may do that. I can see the minimum is at -1, and then it goes as high as 5. So the first line I would draw on this graph is the midline. And if it's a total of 6 units, then I need my midline at 3 units above and below it. So the midline is here at 2. All right. The next thing to note is that I said right in the instructions that we don't have to worry about C in our equation. There is no phase shift, which means the y-axis is the start of a curve. Okay, there's a period starting right at 0, and then you can trace the curve and see that one whole period finishes up by the time you get to 4 pi. So here's the curve to analyze to decide, is this a sine or a cosine? It's starting at a minimum down here. Okay, it's a reflected cosine, isn't it? So the first thing I'm going to write is that I recognize this is a negative cosine. Okay, that's going to be important. Okay, the next thing that's pretty easy to figure out is because the vertical shift has a midline is at 2, what is the value of D? Okay, 2, right? The other thing that should be pretty easy to determine is the amplitude. Although some people have missed this, let's clarify. The amplitude of the curve is its height above the midline. So if my midline is right here, okay, and the highest point is up here, okay, as far as your amplitude goes, all right, the amplitude is 3 units. Don't say the amplitude is 5. All right, the amplitude is 3, so A is 3. So we know it's going to be negative cosine. The amplitude is 3. The midline is at D, or at 2. The only one that's at all tricky with these is to determine the value of B, and that is based on the fact that the period finishes up at 4 pi. All right, now, don't tell me that B is 4 pi. B is not 4 pi. Okay, the period, though, should equal 2 pi over B. And so I typically have written that formula. Where do we drop 4 pi in that equation? Okay, on the left side. The period is 4 pi, so set 4 pi equal to 2 pi over B. And then solve for B. All right, there's lots of ways to do it. This one you don't really even need to think of it as a proportion, but you could. All right, you get 4 pi times B is equal to 2 pi. And so to solve for B, you need to divide by 4 pi on both sides. So the 4 pi's cancel here, the pi's cancel on the right side, and B is equal to 1/2. And that's all we need to know. Put all that together and you have y equals -3 times the cosine of 1/2 x plus 2. All right, this is a question that you can check your answer, and it will have one of those circle yes or no questions. So how do we check our answer? Okay, the same way we did in the last question. Okay, choose a couple points that the curve passes through and make sure they're solutions to the equation we just wrote. So I'm going to test those 2 points. The minimum point at the very start of the curve had a coordinate of 0, -1. And then that intercept would have been at pi 2. So those are xy points that my curve passes through. They should be xy points that are solutions to the equation. So in radian mode, -3 cosine of 0.5 times 0, close the parenthesis and add 2. That one works. Pi 2 also works. So check 2 points on the curve to verify they match the equation.